Alright, chemistry. New day. New section of notes, I guess, right? So, yesterday, or whenever the last time you watched a video was, I guess, explained little things about measurement, talked about the beginnings of dimensional analysis. Um, hopefully I had you do these questions. There should be blank versions of all the notes on my CBA on the my main page. There's just a blank version. So if you want to look at it and just like write stuff down, jot stuff down on it, you can even type in it. I think it's a Google Doc, so you should be able to kind of type in it, highlight stuff, whatever you think you need to do. My completed versions will be in the topic section. So as we kind of do each topic, I will have the filled in versions. But for the blank version, there is now a blank version. So if you were doing question 1, down there, right? So 25 liters into gallons, set up your fraction, liters, started from the bottom, now we're here. So liters in the bottom, gallons on the top. Set up your conversion factor. It's given to you here, 1 gallon is 3.785 liters. You'll notice this is slightly different than the examples that we did, that I showed, right, in the last video. Previously, it was all multiplication. This one has some division. It's fine. Type into your calculator. 25 divided by 3.785. You can multiply by 1 if you want to. You don't have to. Anything times 1 is just itself. When you do that, you should get 6.6. Gallons is our units because this liter is on top, this liter is on the bottom. Totally cancel out. They no longer bother us. There it is, rounded to the nearest tenth. I also asked y'all to take a look right here at 67 centimeters to inches, and again, we have that 1 on the top and 2.54 on the bottom. The reason for that, we started in centimeters, that goes in the bottom. Now we're here in inches. So 67 divided by 2.54, again, rounded to the nearest tenth, is 26.4 inches. Hopefully those went okay. The next piece is being able to actually convert from centimeters to meters. So we're back up in the notes and we're right where we left off. You can convert between units in the metric system. So centimeters to meters is the example here. I could go liters to milliliters. I could do kilograms to grams, right? As long as I'm going from the same unit to unit. When you're converting within the same base unit, and a base unit is a meter or a liter or a gram, right? You're always going to convert from one thing to another. I'm never going to ask you to convert from meters to kilograms because that just doesn't make any sense, right? So anytime you're doing that, the unit equality that you use will come from information on table C in your reference table. And up until this point, we hadn't had a reference table, but I remembered, totally remembered, 100%, to download it. So I put this also on the MyCBA page. You should see it. It should just be a download link, reference table, click on it, boom, here it is. And if we look at table C, what we see is selected prefixes. Some of them you might recognize. Kilo, you should probably recognize. Centi, like a centimeter, or a milliliter. Perhaps you recognize nano, just because you've heard kind of like in the news or in science news, nanotechnology. Micro, like a microscope, right? Looking at small stuff. So all of these with negative exponents represent kind of smaller units. And then with the positive exponent, just the one with the positive exponent, that's a larger unit. Anyway, here is where you're going to look if you're converting from metric unit to metric unit in the same base unit. Again, I'm going to do an example, and then I'm going to bring you back to here. So let's take a look at an example. The example that I'm going to use is I'm going to convert 1 kilometer. Ooh, there we go. I want to turn it into a certain number of meters. Now, spoiler alert, it should end up being 1,000. Let's make sure it is. Let's set up our fraction. Started from the bottom. Right, we started in kilometers, so we put kilometers in the bottom, and now we're here. I want to end up in meters. There is a single very important rule when you are converting from something in metric to something else in metric. And that very important rule, which I'd like you to write down somewhere, or type it in somewhere, right? If you're using the digital version of the notes, type it out. If you like a physical copy, or you kind of like have your own little notes that you make when you go along, please write this down. Maybe you have you print out a copy of the reference table for yourself just so you have it to look at. Please write this down. The rule is with the prefix. The rule is one goes with the prefix. What that means is that I've set up my my fraction with units, but I have no numbers yet. I need numbers. I need numbers to do math. That's still pretty much always the case. Here, there are two numbers to fill in. One of them will always be 1. If you're going metric to metric, one of your numbers will always be 1. And in this case, the 1 is going to go here. The reason it goes there is because if you look, see how kilometers, this has the prefix. This has no prefix, but this unit has a prefix. And because that unit has a prefix, I'm going to put the number 1 there. Now, what number do I put up here? Well, that's where the reference table comes in. Remember, my prefix is k. So if I check my reference and I look for the symbol k, then I find the factor, I find the number 10 to the third. So this is a number that I'm going to write into my fraction. 10 to the third. And now I do math. Kilometers cancels kilometers, this 1 cancels the 1, and I end up with 10 to the third, which is also 1,000. 1 kilometer is 1,000 meters. What is this? Sync status error. That's weird. One of our services is down. That's awkward. That's fine. Alright, so this is how to do it. It's the same process, right? You're still setting up your fraction. You're still putting the unit that you want to cancel on the bottom, where you want to go on top. The only difference now, 1 goes with the prefix. So whatever the prefix unit is, wherever it is, it could be in the top or in the bottom, you're going to put 1 there. Then you're going to use your reference table to figure out what number it should be based on the symbol. Right? Which means, if I check here, right, centimeters to meters, centimeters in the bottom, meters in the top, 1 goes with the prefix, and centi should be 10 to the negative 2. According to my reference table, centi is 10 to the negative 2. Alright? Do the math out, you end up in a spot. Now, there is a small asterisk, right? You can only use table C if you're going from a prefix unit, so literally something with a prefix, to a base unit. And a base unit is what we call a unit with no prefix on it. Or vice versa. So if you're going from a base unit to a prefix unit, you are not, and I repeat, you are not allowed to use table C and this unit conversion process for going prefix to prefix, because you'd run into a problem. Both numbers would be 1. We'll deal with that scenario in the future, but right now, let's get this set. Question 3 and question 4, right, on page 2 are things that I would like y'all to try. I'm going to skip ahead just the tiniest bit because I want to talk a little bit about scientific notation. Right. Now, I recognize that there's a little section about graphing here. The only thing that I would like you to remember about graphs is that graphs don't only tell you stuff about what's on the graph. If you looked at a graph and the graph looked like this, you can tell that this is trending upwards, right? So theoretically, you could tell me, you could guess what's going to happen right here. the graph is probably going to be somewhere here, because this line is just going to continue to extend upwards. It's very unlikely that this line does something wacky like zigzag or curve, right? So if I asked you to guess what would happen here, you would probably be up here. If I asked you to guess, well, what happened, back here, you'd probably end up a little below. You'd end up kind of down here. So graphs can be used not just to look at what you literally measured, but you can also look at what's going to happen in the future and what might have happened before you started measuring. Now, when we're working with numbers in chemistry, we tend not to look at kind of normal numbers. We tend to look at numbers that are really big or really small. And in order to make them easier to look at and easier to do math with, easier to analyze, we use something called scientific notation. Now hopefully you've seen this kind of term before. Ooh, what was that? This kind of term before? If you haven't, I'll explain it, right? So this number here, 2.25 times 10 to the negative third, that is a number that's in the form of scientific notation. You'll notice there are two parts to it, right? The first part of notation, right here, is going to be some number between 1 and 10. The second part of the number, right here, second part of notation, is a power of 10. So this one is 10 to the negative third. We write it in exponential form, which just means 10 to the something. Right. Now, this exponent, this number up here, the actual number, the 3 or the 7 or the 22, whatever number it is, I can figure out what that is by counting how many times did I move this decimal place. If I look, it started here, but I made the number 2.25, so I took the number and I moved it 1, moved it 2, moved it 3 spaces, and that's how I got to the number 3. 1, 2, 3 spaces. Again, that's how I got to the number 3. In order to figure out what sign is going to be up here, what I'm going to do, is look at the original number, right? If I want to express numbers that are larger than 1, then this exponent up here is going to be positive. You notice that's not the case, right? This number, 0.00225, that's a small number. That's a number that is less than 1. So my exponent is negative. That's how scientific notation works. That's how scientific notation runs. Right? Further on in the notes, right? In the blank notes, which I will try to bring up here. Give me just a half a moment. And there they are. Should be magically on screen. Cool. So in the blank notes, right, I would like y'all to try to do number 3 here and number 4. These are the conversions of metric units to metric units. These are using table C. In addition, I'd also like y'all to look all the way down on page 5. That might seem strange, but page 5 is kind of like the last page of this section. I'd like you to look at page 5 because right here, these two, this section, I would like y'all to try to put this number right here into scientific notation. I'd like y'all to try to take this number right here out of scientific notation. All right. Now that may be a little tough. That may be something that I will definitely lead with that in my next video. If you have questions, please email me. Feel free. I'll make a little example for y'all. All right. I don't want to leave this going too long. I've already talked for almost 15 minutes, and that's like 5 minutes longer than I wanted to go for. But if y'all have questions, please let me know. I'm going to stop right there. You have your couple things to do. Again, email me with questions, and I'll post a new video soon. Take care, kids.